For this problem, we're dealing with a collision on a horizontal plane. This is a two-dimensional version of a conservation of momentum problem. So we're going to have to find both the x and y components of the momentum for each object in the system. So in this case, we have two chunks of ice sliding on the surface of a frictionless frozen pond. Chunk A has a mass of 5 kilograms, so we can write that down. It's 5 kilograms. And it has an initial velocity of 2 meters per second, and that's parallel to the x-axis. It collides with chunk B that has a mass of 3 kilograms and is initially at rest. So its initial velocity is 0. After the collision, the velocity of A is found to be 1 meter per second. In a direction at an angle 30 degrees. So we're being asked to find what's the final velocity of B. And we need to know both the magnitude and direction of this. So the first thing I'm going to do in this case is try to find the after. I'm going to try to find the after in x components. So let me separate right here. We are focusing only on the x components right now. So the first thing we're going to do is, like in all of our other problems, we're going to do the mass of A times the initial of A, which in this case is, oh wait, no, we're doing the after right now, so it'll be the final of A. So we know that that's 1 meter per second, this one right here. And we also are trying to find at the angle. So we know that A is going at this angle. So we're going to do the cosine of 30. And then we'll add on the mass of chunk B. And we're trying to find the final velocity of chunk B. And this one doesn't have an angle that's acting on it. So the first thing we can do in this case is multiply by 0 on this side. So we would move everything around and equate it to our initial. So before the blocks even collide, we know that chunk B, the 3 kilograms, is being multiplied by 0 because that's its initial velocity. So we're gonna equate the initial x components to the final x components. So we have the 5 kilograms, we have the 1 meter per second, and we have the cosine of 30. And then we have this plus the 3.0 kilograms times the final velocity of chunk B. And now we're going to equate this to the 5 kilograms and the initial velocity of A, which is 2.0 meters per second. We're not going to put the mass of B or the initial velocity of B because we know it ends up being 0. So now here we can start canceling out different values. So once we figure this out, we have 3 kilograms times the cosine of 30 times the final value of chunk B, and this is equal to the 10 kilograms times meters per second on the other side. And once we divide both these sides and only solve for the final velocity of B, we get 1.89 meters per second. So that is our x component for the final velocity of chunk B. And now we're going to go on to the y components of chunk B. So let me write it right here. Y components. Okay, and for the y components, we know that the before is equal to 0 because there was only movement in the x direction, and then the block over here was static, it was not moving at all, but this one was moving in the positive x direction. So to get these y components, we're just going to add them up like before, and we're going to equal them to 0, because the before and the after should be the same. So we will equate this to 0, and now we're going to get the mass of A times the 1 meter per second, that's the after in the y direction. And now, since we're trying to find the angle that's in the y direction, instead of cosine of 30, we're going to do the sine of 30. And that's going to be plus the 3 kilograms of chunk B. And then we're solving for the final velocity of chunk B in the y direction, just to specify. So 0 is equal to the 5 kg times ms times the sine of 30 plus 3 kg final velocity of chunk B. And once we solve for this, the final velocity of B in the y direction is going to be negative 0.83 meters per second. Now we're also being asked the direction, so now we're going to try to solve for the angle now that we have both the components in the y and x direction. So to find the magnitude, we're going to use the Pythagorean theorem. So we're going to do a radical 1.89 meters per second, the x component squared plus the negative 0.83 meters per second squared. And this gives us 2.1 meters per second. That is the magnitude of the final velocity of B. And now let's get the angle, the direction in this case. So the inverse tangent is going to be y over x, and our y is 0.83. And then 1.89 is our x. And this leaves us with an angle of negative 24 degrees. So that is the direction.